Hello and welcome back. Alright, so we've taken a look at data types. We've taken a look at what the binary representation of those data types looks like. It's all kind of abstract. Let's go ahead and move that into a little more tangible world. So we're actually going to create a little C++ program. I'm going to be using Xcode. If you're following along in Visual Studio, it should work just fine. But yeah, so let's go ahead and learn how to declare our variables, and then we'll learn how to output that data to the console, and then we'll also learn how to grab some data from a user. Alright. So the first thing I'm going to do is I'm going to declare each of my variables that I'm going to be working with. So we have a boolean, my bool, a char, my char, int, my int, float, my float, double, my double. Alright. So what we have here are 5 different variable declarations. The way in which you define a variable in C++ is that you have the type of variable, so in this case, bool. Then you have some sort of white space, a tab, enter, any of that. And then you have the identifier name, the name in which you are going to reference your variable later on in your program. So C++ has some strict guidelines on valid identifier names. The first is that it has to be, the first character has to be either an underscore or a character, a letter in the alphabet. After that, it can be followed by an underscore, a letter in the alphabet, or a number. It also has to be contiguous. There can be no spaces, so I can't change the underscore in here to a space. Those are 2 totally different things. And you can see Xcode tries to colorize it based on what it thinks is the right thing. I think that's about it for identifier names. You also can't name them something that's already what's called a keyword in the language. So all the built-in data types are keywords. There's also some other ones like this return statement down here. You couldn't call your Boolean return, for example. Xcode highlights it, so that'll be kind of an indicator. If you ever see your variable name get highlighted this color, this kind of magenta color, then you know that identifier is actually reserved. You also get compiler error when you try to compile your program. Alright, so we have our 5 declarations for our variables. So let's go ahead and learn how to assign data to those variables. So there's 2 ways we can do that. We can either do it in line with our declaration, which I'm going to do right here, equals true. The Boolean is special. It has some built-in types for us, or 2 built-in valid values. There's the true value, and then there's the false value. So just like we learned, it takes true or false. Those are the two keywords that we use to assign some data into a bool. So for a character takes a single character, and so the way we represent that in C++ is with a single quote, which is the apostrophe key, and the character, and an apostrophe. If you try to do something like this, the compiler will complain and tell you that's invalid. Let's look at it another way. So we already have our variable defined. I can come down here and also assign a value to my integer. And let's say my integer is 11. We don't actually have to add new lines. The only important thing that we need to add are the semicolons. And these are basically a way to tell the compiler that your statement is complete. And so a statement is essentially this block. Okay, so we have my float, my int, and let's do my double. So I don't actually recommend doing the whole doing this right here. It can get confusing, but just note that you can do that. Alright, so I declared that there looks to be nothing different between these two, and in fact there really isn't when I specify it like this. I can put an F at the end of this float variable to tell the compiler that the 12.3 is indeed a floating point number and not a double. So what happens under the scenes when you try to assign the 12.3 to the double, or to my float, the compiler says, hey, you have a rational number. I know what that type is, and so I'll just assume that it's a float based on what you're assigning it. And so when you use the F, you specifically tell the compiler that you're dealing with a float number. So in this case, it's not really that important, but it could have various outputs in your program, so just be aware. And also, it's not uncommon to see 12.3 or a number dot something and an F. Also note that you don't, if you're actually going to write 12.0, you don't actually need to write the 0. You can just do 12 dot and then F, and you'll be fine. Okay, so let's go back to 12.3 F. All right, so now we have defined our variables. We have assigned values to all of our variables. Let's learn how to output the values for each of those variables. So in our intro program where we talked about the basic structure of C++, we saw this cout object. So we're going to use that again. And so it's standard : : We need to scope it. It's in this thing called the namespace, which we'll learn about later. But for now, actually to make it easier, I'm going to go ahead and do this using namespace standard up here. Basically, this tells the compiler to look for any of our identifier names that we'll be using in this standard, or in this namespace called std. And so this IOStream class defines a namespace and scopes them all in, so whatever, kind of hand-wavy right now, that's fine. But just suffice it to say, that means I don't have to type standard : each time I want to use these things. And so for this video, that'll be helpful. All right, so we'll go cout, and then we're going to input a string that we want to kind of prefix our values with, so we know what we're outputting and what it corresponds to. So we'll say my bool equals, and then we'll end our string. And so note that these are actual quotes, not single quotes. All right, so we have my bool and end line. Then we will do my char. Say my char equals my char. My int equals my int. My float equals. My double. Okay. So we have our cout statements. We have our double less than operators. We have our string. We can chain these together to base the way cout works. We can specify a type, or our variable that we want to output. And so let's see what this looks like. So we'll go ahead and build, then we'll run, and we need to bring up the console. All right, so we have my bool equals 1. So booleans are represented as zeros and ones in the computer. So 0 is false, 1 is true. So it's just handy that we can type true here, just more clear, makes our code more readable. But the computer is going to interpret that as a 1. That's what it's actually going to output. So my char, we set it to the character D, and so we get the character D out. My int, we set it to 11, good. My float, 12.3, perfect. My double, 3.14, perfect again. Okay, so we have been able to assign assign data to a variable. Now let's go ahead and look at some of the basic operators that we have for these types. So basically what we're going to work with is the mathematical operators right here. And so we're going to have plus, or addition, subtraction, multiplication, and division. And there's two things that I want to show you. The first is what happens when you, well, let's actually just do addition first. So cout. So we can do our variable names, or we can do constants. So let's do a mixture of both. So we're going to do 4 plus my int equals, and then we're going to do the constant 4, and then we're going to do the plus symbol, my int, and line. And so that reads pretty much just like you would on a piece of paper if you're writing out some mathematics. Alright, so the next thing I'm going to show you is the division for integers. This kind of trips up some people. So we use the / for division, or for divide. So let's do my int divided by 2. And so I want you to go ahead and guess what you think that value is going to be. Alright, and then we'll do my float times my double. Alright, that's good enough. Build it and run it. We get all of our data printed out again. Not too terribly exciting. Alright, so now we have 4 plus my int. Remember, my int is 11. So 4 plus 11 is 15. Very good. My int was 11. 11 divided by 2 is 5. Huh. So last time I checked, 11 divided by 5 was 5.5. But we need to remember that in C++, we have these things called data types, and the compiler assumes that if you're working with a specific type, if all of these are integers, it's going to assume that the type of value that you want back is an integer. So you can't represent the value 5.5 as an integer. So what does it do? It just simply throws away the decimal portion. So any remainder that you get during division, it just throws away when you're dividing ints. If you were to have, I shall go ahead and show you that in a minute. So my float times my double, 38.622. I'm going to trust that that's what 12.3 times 3.14 is. Looks about right. Alright, so what happens if you actually wanted the value 5.5? What would you do? So let's clear the log. Let's jump back over into our code. So there's two ways that you can go about fixing this. The easiest way, well, the most straightforward way, I guess, in my opinion, is to simply change the to value from an integer to be a float. So we can do period f, build it, rerun it, and you'll see that the output is indeed 5.5. Oh, I just didn't update my string. So it's actually dividing it by 2.0. So what the compiler says is that, hey, I have an integer divided by a float. Oh, you actually want, well, it's actually, yeah, so sorry, it isn't, it's a float. So what the compiler says is that, okay, you have an integer, you have a float. What you really want is you want the value stored in the best data type available based on those inputs. And so it's going to store your result as a float because the float is going to be able to carry on more of that precision. And so that's what's happening in the background there for you. The other way we could do it is we can do this thing called casting. There's different types of casts in C++, way out of the scope for this video. But this, suffice to say, this is the easy way to do it if you actually need that data out. And I just want you to be warned of the integer division problem. But basically just the semantics. So in case you ever do something like 5 divided by 3 and you wonder why your answer is 1, you'll know why. You did integer division. Alright, so we have assigned variables, we have declared variables, we have output variables. Now we need to actually read in some variables. So let's go ahead and delete all this code. We don't need it anymore. And we're going to create an int called n1. And we're going to print out a nice little message for our users. Input your age. And then we're going to do cin. So cin is the special object that we use to input data, or we use when we input data from the console. Cout, remember, is the way we output data. So we use the less than symbols when we want to shove this portion of the data into our cout object. So when we want to shove data into our variables, we use the greater than, the double greater than operators, which is a bit shift right operator. So basically the way I like to think about it is that you're shoving this data this way, and cin is you're shoving the input from the console into this variable. Alright, so we input your age, and then we're going to go ahead and output the value. So \n is just a shorthand way of doing a new line, as opposed to the end line. So new line, your age is, and N1. I guess we can call this age. We can do better naming conventions. Naming conventions are actually pretty important. Helps you identify what your code is actually supposed to be doing. It makes your code a lot more readable. Alright, so we built and run it. So you can see that we got a blinking cursor. It's asking us for our age. So I think I'm 28. Alright, so we output your age is 28. Perfect. Alright, so we've gone over declaring variables, how to output variables, how to assign data to variables, how to read input. We've looked at some of the basic math operators that we have available to us. I think that's going to wrap it up for this video. Thanks.